So this is just, it's nothing new. I just want to kind of summarize for you here. Okay. This page is in your notes. I think this would be a good idea for you to go in, fill out, actually maybe try and do it on your own, see how much you remember, go through your notes if you want. But I'm just going to go through really quick and kind of fill this in so that you can have a one-page kind of summary of the important information about the different types of seismic waves. Okay, so we have the three ones that we do need to know kind of the differences between. We have P waves, S waves, and then surface waves. We're not going to bother splitting up the surface waves into Rayleigh and Love. You don't really need to know that. And honestly, it kind of comparing them can be hard because it depends on the types of conditions. Certain areas, Rayleigh waves are worse because of what the ground material is like, and certain areas, Love waves are more damaging because of what the ground is like again. Okay, so first up we have P waves. Remember what P stood for? P was for primary. Okay, P is for primary. The S, well, S we said stood for a lot of things, but really, what does the S stand for? It stands for secondary, as in right after the primary. Okay, and then we had our surface waves. What's the full name? I mean, surface waves is the full name. If you want, you could say Rayleigh or Love. Again, you don't actually need to know the difference between Rayleigh or Love. It's just extra information, and that never hurt anybody. Okay, now we're going to classify these all by whether they're body or surface waves. So P waves and S waves. Remember what those were? Those were both body waves. Okay, they were the two types. Obviously, what's a surface wave? Well, that's going to be a surface wave. Rayleigh and Love are both surface waves, and that's all we really need to know. Okay, so relative speed, it's asking us to rank them from fastest to slowest. So what's the fastest? If you are in Fort McMurray and an earthquake happens in Calgary, which types of waves are going to reach us in Fort McMurray first? The P waves, primary. That's why they're called primary waves. They're the first ones to get there. So they are first. They are fastest. Okay, what arrives after the primary waves? You betcha, the secondary waves. They are second. Okay, second fastest, which means the slowest are the surface waves. Then it asks us to rank them from most damaging to least damaging. Now we kind of got lucky with this, that earthquakes work this way, because turns out the first ones to arrive are the least damaging. Okay, and then the second ones to arrive, they're the second most damaging. Why did I say we kind of got lucky with this? Well, that way, when the P waves arrive, we can get ready. We can make the preparations we need to for the bigger, more damaging waves that we know now are on their way, right? Right? It would kind of suck if we got hit with the surface waves first. We had no idea anything was coming, and boom, the most damaging waves arrive. So we're kind of lucky that it goes in that order. It allows us to get prepared. Okay, what can they travel through? Well, P waves can travel through all three. Okay, S waves, remember, cannot travel through liquids or gases. They can travel through solids only. We can think of the S as standing for that. S for solids only. Okay, so surface waves can travel through solids or liquids, but remember, they can only do that along the surface. They can't go through the earth. Okay, quick diagram showing the motion. So remember, a P wave, think of the P for compression. So in a P wave, the material moves side to side, and so does the wave. So if I picture like a slinky, okay, we have compression, but then after the compression, it kind of gets spread out. And then if this is another wave, we kind of get compression, right? And so the wave itself moves this way, right? And a particle that's part of the wave is also, if it's a slinky, right, it's also moving at least in the same axis, so side to side, right? It might move backwards, but it's still just moving side to side. It's not going to suddenly start moving up and down. Whereas for a S wave, looks like an S, remember, or at least an S turned sideways if we're drawing it this way. But now, if you're a particle here, what are you about to do, right? You just moved up, you're about to move back down, right? So if you're now, the material is moving up and down, even though the wave is going that way. So see how that's perpendicular? It's at 90 degrees, okay? So the wave moves side to side, let's say. That means the particles are going to move up and down. Or if the wave is moving up and down, the particles are going to move side to side. Surface waves depends on the type, if it's Rayleigh or Love, okay? Again, you don't actually really need to know this, but essentially for Love, you have like a snake, kind of side to side like this. For a Rayleigh, you actually have kind of a rolling motion. So it kind of looks like that. Okay, now this is really important. A diagram showing how they can travel through the Earth. Okay, so let's go ahead and draw this. This is probably the most important thing to take away about these seismic waves. So here's our Earth. Okay, if you are a P wave, and I'm actually going to draw some stuff in our Earth. I'm going to draw the outer core and the inner core. If you're a P wave, you don't care. You're the fastest you can travel through anything. Okay, so this is how a P wave can travel. If the earthquake happened here, remember the date with the word from yesterday, what would we call that point? Well, if it's on the surface, that's the epicenter. If it's where the cracking actually started, it's the focus. Okay, so from the focus, notice how they're going through the outer core that's made of liquid. They don't care. They're P waves. If you are an S wave, you're a body wave. So that means you can travel through the earth. Yes, right? But there is a little bit. You can't do everything a P wave can do. Okay, because you can do this, right? You can do that, no problem. Okay, if that's where earthquake starts from. You can do this, no problem. What you cannot do, or at least what you cannot finish doing, is that. You're going to get stopped by the outer core, right? So remember, this is actually how we figured out our outer core was liquid, because we were standing over here and we were saying, hey, there was just an earthquake on the other side of the world. We got lots of S waves over here, but there's this big area where none made it to us. Why is that? Well, because they are S waves and they can't go through a liquid. So, aha, the outer core must be liquid. Okay, finally, if you're a surface wave, you can't do either of those things. If you're a surface wave, you can't do either of those things. You're stuck here. That's all you can do. Stay along the surface. Just at the bottom here too, I'm kind of going to group these really quick. So we'll just say P waves and S waves. What are those both types of? Those are both types of body waves. Okay. And obviously surface waves are surface waves. And just, I know we kind of did in the table, but I just want to show you the order. So from P to S to surface, we go from fastest to slowest, but we do the opposite when it comes to damage, right? These are the most damaging. Surface waves by far the most damaging. To P waves are the least damaging. So in general, surface waves much more damaging than body waves, but also much slower than body waves.